Greetings and welcome to Make Programming Fun Again. My name is Karol Moros, and in today's video we are going to read The Rust Programming Language by Steve Glabnik and others. And the reason we are going to be reading this book is because it has been a popular choice in the polls I made on my channel. And I actually made two polls over the last 2 days. One was asking which language I should use for my side project related to Bitcoin blockchain and Lightning. And the other one was just a poll regarding what you would like to watch tonight. So the most popular choice was the Rust book. And I'm also going to make videos about the other two topics, I guess. Anyway, let's start reading the book. I'm not exactly sure about the formula of this video. Maybe we'll do something similar to the Kernighan and Ritchie videos, where basically we just read the book and I was really learning myself. In the case of this book, I have actually read quite a huge part of it, and I've written some Rust code, just not on a professional level. So I guess to some extent I will be learning alongside you, and to some extent I will be just explaining or mansplaining things. Anyway, I am on macOS because I just decided it's much easier to record with a single machine, and then this will be the same machine I will be editing this video with. This is the same machine I will be editing this video with, and I already have Rust installed. I'm using the latest Rust. I think we can also install latest Rust using Mise. Oh yes, so I didn't have the latest one, but Mise can handle this for us. And actually, the recommended option to install Rust is using rustup.rs, and you can just copy and paste this command. I'm not doing this because I'm using Mise, and Mise uses rustup to install versions of Rust under the hood. So, okay, this book says the first step is to install Rust. We'll download Rust through rustup, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download. Okay, I'm not going to be following this part. I'm not going to be following along with this part because I already have Rust installed. But if you wanted to do it like so, you could do it. And for macOS users, you will also need to install Xcode command line tools, including the C compiler and so on. But I already have these installed. If you are on Windows, I think you can still use rustup. I think they officially support Rust, support Windows. And what else? Okay, I have Rust C installed. I have Cargo, so we can go on and create a Hello World project. And I'm going to read the book first. Hello World. Now that you have installed Rust, it's time to write your first Rust program. It's traditional when learning a new language to write a little program that prints and takes Hello World to the screen, so we'll do the same here. Note, this book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling, or where your code lives, so if you prefer to use an integrated development environment instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check the IDE's documentation for details. The Rust team has been focusing on enabling great IDE support via Rust Analyzer. See Appendix D for more details. Okay, so actually I have created a new Vim configuration for streaming. It's pretty minimalistic. I don't even have like the power line, and I'm going to be doing everything in the command line. So let me start by following along the project. We need to create a directory for projects. I already have one, and then we create a directory called Hello World, and okay, cd Hello World. And now we can create a file called main.rs, function main, println hello world, like so. Okay, I have correct formatting. It's just that I didn't have like any indentation support or anything, but this should work. And then we compile this file using Rust C, and now we should have a file called main, which is executable, and it will print the message hello world to the console. Okay. Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation section for ways to get help. If hello world did print, congratulations, you have officially written a Rust program. That makes you a Rust programmer. Welcome. Anatomy of a Rust program. Let's review this hello world program in detail. Here's the first piece of the puzzle. fn main. These lines define a function named main. The main function is special. It is always the first code that runs in every executable program. Here the first line declares a function named main that has no parameters and returns nothing. If these were parameters, they would go inside the parentheses, left and right parentheses. The function body is wrapped in curly braces. Rust requires curly braces around all function bodies. It's a good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. Also, you could actually try to do this ugly as C# in a C# notation like this. Okay, I can do this because Vim won't let me. It just reformats the code to look pretty. But I think that means we could do these ugly as C# curly braces. Okay. If you want to stick to a standard style across Rust projects, you can use an automatic formatter tool called rustfmt to format your code in a particular style. More on Rust format in Appendix D. The Rust team has included this tool with the standard Rust distribution as Rust C is, so it should already be installed on your computer. The body of the main function holds the following code. Println, bang, left paren, double quote, hello world, double quote, right paren, and a semicolon. This line does all the work in this little program. It prints text to a screen. There are 4 important details to notice here. First, println calls a Rust macro. If it had called a function instead, it would be entered as println without the exclamation mark. We'll discuss Rust macros in more detail in chapter 20. For now, you just need to know that using a bang means that you're calling a macro instead of a normal function, and that macros don't always follow the same rules as functions. Second, you see the hello world string. We pass this string as an argument to println, and this string is printed to the screen. Third, we end the line with a semicolon, which indicates that this expression is over and the next one is ready to begin. Most lines of Rust code end with a semicolon. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of your source file, like this. If you have a C or C++ background, you'll notice that this is similar to GCC or Clang. After compiling successfully, Rust outputs a binary executable. On Linux, macOS, and PowerShell on Windows, you can see the executable by entering the ls command in your shell. On Linux and macOS, you'll see two files. With PowerShell on Windows, you'll see the same three files, but you would see using cmd. With cmd on Windows, you would enter the following. This shows the source file with the .rs extension, the executable file, main.exe on Windows, but main on all other platforms, and when using Windows, a file containing debugging information with the .pdb extension. From here, you run the main or main.exe file like this. Oh, by the way, I wonder if we can debug this using the LLDB compiler, since, Rust is built with LLVM. Okay, it did launch. Can we break on main.rs line 2? Okay. So we don't have any debugger. We don't seem to have any debugger information with LLDB. Okay, we know how to run the code. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead of time compiled language, meaning you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. If you give someone a .rb, .py, or .js file, they need to have a Ruby, Python, or JavaScript implementation installed, respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language design. Just compiling with Rust C is fine for simple programs, but as your project grows, you'll want to manage all the options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. Hello, Cargo. Cargo is Rust's build system and package manager. Most Rustaceans use the tool to manage the Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you are using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following in your terminal. This cargo -- version we do have cargo installed. Okay. If you see a version number, you have it. If you see an error such as command not found, look at the documentation for your method of installation to determine how to install cargo separately. Creating a project with cargo. Let's create a new project using cargo and look how it differs from our original Hello World project. Navigate back to your projects directory or wherever you decided to store your code. Then, on any operating system, run the following: cargo new hello cargo cd hello cargo. The first command creates a new directory and project called hello cargo. We've named our project hello cargo, and cargo creates its files in a directory of the same name. Go into the hello cargo directory and list the files. You'll see that cargo has generated 2 files and 1 directory for us, a cargo.toml file and a source directory with a main.rs file inside. Okay, so if we have a source directory and we have a cargo.toml. Okay. So we can open the source, the main.rs file. It has also initialized, it being cargo, it has also initialized a new Git repository along with a .gitignore file. Git files won't be generated if you run cargo new within an existing Git repository. You can override this behavior by using cargo new --bcs equals git. And what does it say? Cargo new help. Okay, so we can generate a repository with git mercurial, these 2 ones, and none. And there are some other templates, and you can choose the edition of the Rust programming language. In this case, we are building against edition 2024. And we can set the resulting package name, registry to use. I think this uses like crates.rs or whatever it is called. Then coloring config, okay. Go into the hello cargo directory and list the files. You'll see that cargo has generated, okay, yeah, we already did that. Note, Git is a common version control system. You can change cargo new to use a different version control system or no version control system by using the --bcs flag. Open cargo.toml in your text editor of choice. It should look similar to the code in listing 1.2. Okay. This file is in the toml format, which is cargo's configuration format. The first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information cargo needs to compile your program: the name, the version, and the edition of Rust to use. We'll talk about the edition key in Appendix E. The last line dependencies is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We won't need any other crates for this project, but we will in the first project in chapter 2, so we'll use this dependencies section then. Now open source main rs and take a look. Cargo has generated a Hello World program for you, just like the one we wrote in listing 1.1. So far, the differences between our project and the project Cargo generated are that Cargo places the code in the source directory and we have a cargo.toml configuration file in the top directory. Cargo expects your source files to live inside the source directory. The top level project directory is just for README files, license information configuration files, and anything else not related to your code. Using Cargo helps you organize your projects. There's a place where everything is in its place. If you started a project that doesn't use Cargo, as we did with the Hello World project, you can convert it to a project that does use Cargo, move the project code into the source directory, and create an appropriate cargo.tom file. One easy way to get that cargo.tom file is to run cargo init, which will create it for you automatically. Building and running a Cargo project. Now let's look at what's different when we build and run the Hello World program with Cargo. From your Hello Cargo directory, build your project by entering the following command: cargo build. Okay. This command creates an executable file in target debug hello cargo. Indeed. Rather than in your current directory. This is because the default build is a debug build. Because the default build is a debug build, Cargo puts the binary in a directory named debug. You can run the executable with this command. If all goes well, Hello World should print to the terminal. Running Cargo build for the first time also causes Cargo to create a new file at the top level, cargo.log. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to manage this file manually. Cargo manages its contents for you. We just built a project with Cargo build and ran it with target debug hello cargo, but we can also use cargo run to compile the code and then run the resultant executable all in one command. Using cargo run is more convenient than having to remember to run cargo build and then use the whole path to the binary, so most developers use cargo run. Notice that this time we didn't see output indicating that Cargo was compiling hello cargo. Actually, I did see. Oh yeah, we did. Okay, yeah, sure. Cargo figured out that the files haven't changed, so it didn't rebuild, but just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it, and you would have seen this output, like so. Okay, I will just touch the source file, and now it recompiled the project. Okay. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles, but doesn't produce an executable. Okay. Yep. Why would you not want an executable? Often cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, using cargo check will speed up the process of letting you know if your project is still compiling. As such, many Rustaceans run cargo check periodically as they run their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we have learned so far about Cargo. We can create a project using Cargo new. We can build a project using Cargo build. We can build and run a project in one step using Cargo run. We can build a project without producing a binary to check for errors using cargo check. Instead of saving the result of the build in the same directory as your code, cargo stores it in the target debug directory. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific instructions for Linux and macOS versus Windows. Building for release. When your project is finally ready for release, you can use cargo build -- release to compile it with optimizations. Okay, cargo build -- release. Can you also run cargo run? Yes, we can. Okay. This command will create an executable in target release instead of target debug. Let me see. In target, let's see, file debug hello cargo and file release hello cargo. Okay, it doesn't really say too much about. Did you have something like LLD, LD? I think there was a command that would tell you what is actually linked. Okay, so it's LDD. Do I have LDD? Okay. LDD uses LD to load executable files. Okay, what's O2? O2-L debug hello cargo. Release. Okay, so I was kind of hoping to see what libraries we are linking, but apparently not much. Okay, also I need to install the optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles. One for development, when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be built repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build -- release and benchmark with the executable in target release. Cargo as convention. With simple projects, cargo doesn't provide a lot of value over just using Rust-C, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using Git, change to that project's directory, and build. So for example, the command mise I use for installing and managing versions of programming languages. It was written in Rust. And yep, it has been written in Rust. And another tool I'm using has been that has been written in Rust is JJ. Yep, a lot of retooling has been written in Rust. For more information about Cargo, check out its documentation. Summary of Chapter 1. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using RustUp, update to a newer Rust version, open locally installed documentation, write and run a Hello World program using Rust C directly, create and run a new project using the conventions of Cargo. And this is a great time to build a more substantial program to get used to reading and writing Rust code. So in Chapter 2, we'll build a guessing game program. If you would rather start by learning how common programming concepts work in Rust, see Chapter 3 and then return to Chapter 2. So the Chapter 2 is the famous guessing game, and I will not be doing this. I will not be covering it in this video because I don't want to be too long. If you have enjoyed this video, please consider liking it and maybe even subscribing. If you did not enjoy this video, please tell me in the comments. There is no code accompanying this video on GitHub because we were only writing Hello World examples. So there will be an accompanying repository with the next video. And in the meantime, thank you for watching. If you want to know more about my community, you can consider joining the waiting list for my Discord server. Once we hit 100 signups, we will start a Discord server. And until that time, thank you for watching, and I will see you in the next video. Goodbye.